All right, so this is Pre-E3.1, which is talking about synonymous statements. Okay, when we get into E3.1, we're going to have to know how to move a solution into its factored form into an x-intercept form. Okay, so we need to know how all those things are related. When you see the word synonymous, it's like synonym. Okay, so basically, if I have a synonymous statement, that means all these statements basically mean the same thing. Okay, so I'm just going to put here statements that mean the same thing. Okay, so here below I have my statements. Okay, notice it says x equals a is a solution to the polynomial equation big mess. Okay, this is just saying this is an x to the n polynomial, so maybe this is x to the 7th, I don't know. N is your highest degree, okay? And the little a sub n's, all these little numbers here, these are just the coefficients. So maybe the coefficient on this first one is a 3, I don't know, okay? That's just our generic way of writing a polynomial. So if we were giving any polynomial equation and we solve it, we would end up with something like x equals a, where a is just some number, okay? So that's one way of writing it. The other way of writing it is, notice normally when we solve a polynomial we have to factor it. So we would take something like x squared plus 2x plus 1. Okay, we would factor it, which gives us x plus 1 times x plus 1. And then we would solve each of these, which gives me x equals negative 1. Okay, so this first statement is giving it to us in solved form. X equals some number. The second statement is saying that's the same thing as x minus a is a factor. So notice if I move this negative 1 back to the other side, I end up with the factor x plus 1. Okay, so those things mean the same thing. If x plus 1 is a factor, then x equals negative 1 is a solution. Okay, those are related. Okay, the other way is if I were to write this function or this polynomial as a function, okay, what this means is if I were to take this negative 1 and plug it back into my function, it should equal 0. So notice here, if I do f of negative 1, that gives me negative 1 squared plus 2 times negative 1 plus 1. Negative 1 squared is 1. 2 times negative 1 is negative 2. And then I have this plus 1. So 1 minus 2 is negative 1 plus 1. That does give me 0. So that's what this one's saying. If I take the solution, the negative 1, and plug it back into the function, it equals 0. Okay? And then the last new thing, really, that we're getting is whenever we solve our polynomial equation, we set it equal to 0 and we solve, this value that we're getting is actually an x-intercept. Okay? So this is the x-intercept, negative 1, 0. Because when we set it equal to 0, it's the same as setting our y's equal to 0. So all of these things are being determined around the same value. Okay, so if I get x equals a, that means that x minus a is a factor. It means that f evaluated at a should equal 0. And it means that a comma 0, that ordered pair is an x-intercept. Okay, so these are our synonymous statements. I'm not going to ask you to define these like on an exam question or anything like that, but I need you to be able to understand how to go from factored form to solved form to x-intercept. So that's what we're going to do today. Okay, and I guess I'll just leave all that stuff. Okay, so let's look at some examples. For the next few equations, we want to solve for x, and then we're going to write the solution in solved form, so x equals whatever. Okay, we're also going to write it as a factor of the original polynomial function, and we're going to write it as an x-intercept. Okay, so the first thing we want to do is go ahead and solve it. Now here I have 3 terms and my highest power of x is squared, so I can use the quadratic formula or I can factor. I always want to try factoring first. So I'm going to say factor using the sum product chart. Okay, if you learned trial and error, that's fine too. Okay, so here my sum is negative 22. My product is my leading coefficient, which here is 1, times my constant, which is negative 75, which means my product is negative 75. So something I can multiply to get negative 75 that I can combine to get negative 22 would be negative 25 and positive 3. Okay, and then over here, if I do negative 25 plus 3, it gives me that negative 22 that I need. Okay. Since my leading coefficient is a 1, I know that these numbers are going to be the numbers inside my factor. So that means f of x is the same as x minus 25 and x plus 3. Okay, so right away I can go ahead and write in my factors over here. I ended up with the factors x minus 25 and x plus 3. Okay, now I want to go ahead and solve them to get my solutions. So I set each one equal to 0, and I just solve. Here when I move my 25 over, which I do by adding, I end up with x is equal to 25. When I move my 3 over by subtracting, I end up with x equals negative 3. So those are my solutions. So my solutions that I got are x is equal to negative 3 and 25. Okay. And then the last thing they want us to do is write those solutions as intercepts. So this means it touches or crosses the x-axis at 25 and at negative 3. So this would be the x-intercept 25, 0. And this would be the x-intercept negative 3, 0. Make sure you write your intercepts as ordered pairs. Okay? So here our intercept is negative 3, 0 and 25, 0. Okay? So that's all we're doing. We're going to solve, write our solutions in factored form, and then also write our solutions as x-intercepts. Okay? Let's look at a few more. On this next one, again, I have a squared, so that's something I could use the quadratic formula for, or something that I could factor. Okay. Remember, when I factor it, my whole idea is that I'm going to factor it and set it equal to 0 so I can solve. So really what we're doing is we're setting negative x squared plus 4 equal to 0, and we're going to try to solve this. So actually, since we don't have an x term here, I can solve this by extracting square roots, right? Or by my square root method. So I'm going to go ahead and just move my x squared to the other side. Okay. You can also solve this one by factoring. I just want to show this method because a lot of people will solve it using a square root and then they don't know how to put it in factored form. Okay. So to get rid of my square, I do plus or minus the square root on both sides. Okay. Which gives me plus or minus 2 is equal to x. So those are my solutions. So this means x is equal to negative 2 or positive 2. Now, in order to write it in factored form, I'm kind of going backwards from solved form. Okay? What I ended up with is x is equal to negative 2 and x is equal to positive 2. So if I wanted to move this back to the other side, I would end up with x plus 2 equals 0, and I would end up with x minus 2 equals 0. Okay? And then that leads me to believe that had I initially factored this, I would have gotten these factors. Okay? So I'm going to go ahead and write this in factored form. My two factors are x plus 2 and x minus 2. Now here we had a greatest common factor that was a negative. At the very beginning I could have taken out that negative and gotten x squared minus 4, and then this is a difference of squares which would have given me my two factors. Okay, I don't want to know what the polynomial is all factored out, so I don't really care about this negative. I just want to know of the two solutions that you got, which here is negative 2 and 2, what would those solutions look like in factored form? Okay, so once you have it solved, if you don't solve by factoring, you just take your two solutions that you got and move them back across the equal sign, and that shows you the factor that that solution would have come from had you done it by factoring. Okay, and then the last thing we want to do is write them as intercepts. So I take my two solutions, and that would be negative 2, 0 and positive 2, 0. Okay, so I'm just going to write those in. So just solving and then writing our answer the three different ways. Okay, let's look at another one. This one I have three terms. So again, I'm going to try to factor using sum product. Using the sum product chart. Okay, so here my sum would be negative 7, and my product, remember, is your leading coefficient times your last coefficient. So 6 times negative 3 gives me a product of negative 18. So I need something that multiplies to negative 18 that combines to negative 7. Which in this case would have to be negative 9 and positive 2, right? Because negative 9 times positive 2 gives me negative 18. negative 9 plus 2 gives me the negative 7. Now normally we'd be like, okay, so these are our factors, but notice here, my leading coefficient is not a 1, it's a 6. If your leading coefficient's not 1, you have to take these two values, plug them back in for your middle term, and do grouping. So I'm going to take negative 9 and 2, and I'm going to replace this negative 7x. So I get 6x squared minus 9x plus 2x minus 3. Okay, and now I can solve it by grouping. So out of the first pairing, I can take out a 3x, which leaves me with 2x minus 3. And then here I want to be left with 2x minus 3, so the only thing I can take out of that next pairing is a positive 1, because a positive 1 doesn't change the value. Okay, so now both of my terms have 2x minus 3. When I factor that out, I'm left with 3x plus 1. Okay, so here I have it factored, so I'm going to go ahead and put my factors in. My factors would be 2x minus 3 and 3x plus 1. And then I'm going to go ahead and solve each one. So I have 2x minus 3 is 0, 3x plus 1 is 0, and then I just solve them. So here I move my 3 over by adding, which gives me 2x equals 3, and then divide off my 2, so I get x equals 3 halves. On the second one, I move my 1 over by subtracting, which gives me 3x equals negative 1, and then I divide off my 3, so I get x equals negative 1/3. So those are my two solutions. I'm going to write in x equals negative 1/3 and positive 3 halves. Okay, leave your answers as simplified fractions. Don't give me decimals. And then I want to write these two numbers as x-intercepts. So the first x-intercept would be negative 1/3, 0. The next one would be 3 halves, 0. Okay? All right, let me look at a couple more, and then you'll be able to do your worksheet. Okay. 3. Okay, so here I have two terms. Now notice I did want to point out, sometimes they don't give it to you in function form. Sometimes they give it to you as a polynomial function. Sometimes they just give it to you as a polynomial equation. So here we don't have an f of x. They just went ahead and set it equal to 0 for us. We do the exact same thing. We're still just solving. And then once we've solved, we write our solution, we write our factors, we write our intercepts. Okay, so I noticed right away that this is a difference of squares. Difference of squares. Okay, notice my base for the x to the 4th would be x squared, and the base that I have to square to get 1 would be 1. So that means this factors into x squared plus 1 and x squared minus 1. Okay. Now notice here again we have another difference of squares, and this time my base, oops, that's not how you spell square, you just abbreviate square. Alright, this time my base is x and again 1, so this one's going to factor into x plus 1 times x minus 1, but this one, the first factor, x squared plus 1, we don't have a rule for sum of squares, so I'm going to go ahead and just leave it the way it looks. Okay, I'm going to go ahead and solve each one. So x squared plus 1 equals 0, x plus 1 equals 0, x minus 1 equals 0. When I solve this first one, I move my 1 over, which makes it negative. X squared equals negative 1. And then I take the square root of both sides. When I do that, don't forget your plus or minus. Okay. Now here, the square root of negative 1, okay, the negative makes it an I, and I'm a complex number, so I have to pull out an I, and then the square root of 1 is just 1. So here I end up with x is equal to plus or minus I. Now, plus or minus I is a solution, but that's not going to give us an x-intercept, right? Because we can't graph complex numbers on the real number plane. Okay, so I am going to go ahead and include this with my solutions, but when I write my intercepts, I'm not going to include it because I only want the x-intercepts that are real numbers that I can actually graph. Okay, so let's go ahead and solve these other two. When I move my 1 over, I get x equals negative 1. When I move this one over, I get x equals positive 1, which means that my solutions are negative 1, positive 1, negative I, positive I. Okay, and then we want the factors, which we can see here. We had the factors x plus 1, x minus 1, but then we had x squared plus 1, right? Since that has an x squared, it's kind of assuming that that's not fully factored. So what I'm going to do is I'm going to take my solutions that I got from there. I got x equals positive I and x equals negative I, and I'm going to move those back across the equation to see what it would look like in factored form. Okay, so if I move my I over, this would give me the factor x minus I equals 0. And over here, when I move my I back over, I get x plus I equals 0. Which means, had I been able to factor x squared plus 1, it would factor into x plus I and x minus I. So I'm going to go ahead and write in those factors as well. X plus I, x minus I. Okay. And then the last thing we do is write our intercepts. So our real number intercepts would be negative 1, 0, and 1, 0. And I'm just going to put a note here. Don't include complex intercepts. Okay, because we cannot graph complex numbers on a real rectangular coordinate system or a real graph. Okay. All right, let's look at one more. All right, so on this one I have two terms. Again, I'm looking for a difference of squares. Here I don't see that I have one. So I'm going to look for a greatest common factor instead, which here would be x, which leaves me with x squared plus 9 equals 0. And then here, this again is still not a difference of squares, so I'm going to go ahead and solve it the way it is. This means x equals 0 or x squared plus 9 equals 0. First one's already solved for me, x just equals 0. Second one, when I move my 9 over, I get x squared equals negative 9, and then I can take the square root of both sides. When I do that, don't forget your plus or minus. So I end up with x is equal to plus or minus 3i because there is a negative under the radical. Okay. So my solutions are x equals 0, positive 3i, and negative 3i. Okay. So I want to go ahead and write out my factors. Now my x minus 0, notice here, if I were to move that 0 back over, I would have x minus 0 equals 0, which is still just x. Okay, so notice that factor here is just an x. And then I want to write the factors that came from my I solutions. So if I have x equals 3i and x equals negative 3i, if I were to move those back across the equal sign, I would have x minus 3i as a factor, and I would have x plus 3i as a factor. So I'm going to go ahead and put those on. So factored, this is the same as x times x minus 3i times x plus 3i. Again, if we did have a greatest common factor or something that wasn't a variable factor, we don't have to include it. I just want to know, of my solutions, what do those solutions look like as factors of this polynomial? Okay, and then I want to write out the intercepts. Now, because these are complex, we don't include them. Okay, so I'm going to go ahead and put here, don't include complex intercepts. Okay, because we can't graph them on the real number graph. So the only x-intercept I have is the only real number answer I got, which was 0. So the only intercept I can use is 0, 0. Okay. All right, that is the end of Pre-E3.1. You have a worksheet that's due for this section. If you print out these notes, the worksheet is page 5 and 6 of these notes. Or if you don't print out these notes, then you can just go to your Math 118 tab in your My Math Lab course homepage, and there's a worksheets tab under Math 118, and you'll be able to find this there. Okay, let me know if you have any problems or questions.